Hey y'all, this is Mrs. Anderson. This is your first video over points, lines, and planes. Make sure that you've gone through and done your vocabulary. If you haven't, pause the video and do that before you watch because it will be a lot more helpful, I promise. So, geometry has a foundation that you need to make sure you have a good understanding of. And that is that we have some undefined terms and we have some defined terms. Your undefined terms are your points, your point, line, and plane. And basically, point is a location, and it's used in the description of a line, which is basically a straight path that extends in two opposite directions. It doesn't ever end, and it doesn't have any thickness, and it has infinitely many points in it. And then a plane, which has the term line in its definition, is a flat surface that extends without end and it has no thickness. A plane contains infinitely many lines. In geometry, when we draw a point, we usually note it as a dot. So this right here would be point A. A line is what you're used to drawing as a line. Oops. It's going to have two arrows on both sides. Typically, it'll have a lowercase letter on the outside, so we can call that line L, or you could have 2 points, and we would call that line AB by drawing it like that. And then our plane, this is kind of hard, obviously, if it's a flat surface that extends without end. So we have to be able to draw that somehow. So usually what you're going to see is a plane draw similar to the shape of a parallelogram. Now don't mistake that. Let me try that again. Don't mistake that and think that a plane is a parallelogram because, quite frankly, it's not a parallelogram, but we have to be able to draw it. So we could call this plane P. Notice it's a capital P. But it doesn't have a dot next to it, so P is not a point. Whereas if we put, say, point A, point B, and point C, we could call this plane A, B, C, or any order of A, B, and C, CBA, BAC, and so on. So these right here are your undefined terms. Okay. Now you also have 3 defined terms, and that's going to be your segment, your ray, and your opposite rays. So your segment is going to be a portion of a line. It's going to be similar to a line, but this time the endpoints are going to be actual points, or we actually call them endpoints. So we would name this similar to the line where we would use C and D, but our symbol above would be that of a segment, basically. Array is going to be what you would, would assume to be array anyways. It's only going to have one arrow on it, and when we draw it, it's very, very important that you label the arrow in the correct direction. So notice how the arrow's on the side where the point B is. So when we draw the symbol above the AB when we're naming that ray, we need to make sure that we also put the arrow above the B. And our last defined term is opposite rays. Opposite rays do form a line, so we can either draw them separately facing away from each other, or we can draw them as one single line. It's very important that you remember that it does form a line, which means they would have to go in opposite direction, and they have to have the same end point. So D is your end point. Okay, and just to go ahead and make this consistent, this was our segment, this was our ray, and this was our opposite rays. And to name those, basically we would just say, for example, DC and D. Notice how the arrow is above the C and it is above the E. And these were our defined terms. Okay, so there's a couple postulates that you need to make sure that you're familiar with. These are actually going to be very important for this entire course. So it is extremely important that you understand these postulates and you remember them and you have them embedded in your brain, because these are going to be the underlying source, as you would say, for the majority of what we're going to be covering in this class. So just in case you forgot, if you don't have your vocabulary next to you, a postulate is also called an axiom. I'm going to call it postulate, but sometimes it's called an axiom, and it's an accepted statement or a fact. Okay, so for the first postulate, this postulate 1-1 says through any 2 points, there is exactly one line. So through any 2 points, there's exactly one line. So basically what that means is if I were to draw point A and point B. Okay, so I've got point A and I've got point B on my slide or on my iPad. How many lines can I successfully draw through those 2 points? Well, according to this postulate, I can successfully draw one line. Okay, now that doesn't mean that I can draw one line and it's going to have exactly 2 points, because the definition of a line says that it has infinitely many points. The postulate says that if you have 2 points, any 2 points, doesn't matter what they are, there is exactly one line that passes through them. So in this particular case, I've got points A and B. I've got one line that I can draw, and I'm going to call that line T. So I would say, in words, line T passes through points A and B. Line T is the only line that passes through both points. So there's your first postulate. Postulate 1-2 says if you have 2 distinct lines intersect, then they intersect in exactly 1 point. So if I have, say, line, I don't know, line C, D, and then I draw line E, F. According to this postulate, there is only one intersection point, and that point in this particular question, we're going to call it U. We'll call it U. So if I have 2 distinct lines that intersect, then they intersect in exactly 1 point. So for this picture that I drew, we would say that CD, or lines CD and EF, intersect at point U. The third postulate says that if 2 distinct planes intersect, then they intersect in exactly one line. So as you can see in this picture, the white plane, which we would call plane RTS or RST or STR, intersects the yellow plane, which we could call plane STW, at one line. So think basically maybe taking one piece of paper, and if you tried to take a second paper and put it through the first paper, it would only hit it at one line. It would basically be the edge of one of the sheets of paper. Okay, the last postulate is the fourth one, postulate 1-4, and this one says through any 3 non-collinear points there is exactly one plane. So obviously we know that collinear points from our vocabulary means that they lie on the same line. So if you think about non-collinear points, non-collinear would mean that they are not on the same line. This postulate can sometimes be a little challenging just because of the requirement that it provides for you to be able to visually kind of see what's going on here. But basically in the picture, points Q, R, and S are non-collinear. So plane P would be the only plane that would contain them.